welcome back. So what we're looking at today is 5.10 taken out of context. So let's go ahead and jump right in. All right, so for each of the systems of inequalities, determine if the given coordinates are solutions to the system. Show your work. So what we're going to take and do, just like when we're given regular systems of inequalities, we have to have the coordinate work for both of the equations. So we're going to plug in the point 610 for x and y in the first equation and the second equation to see if it works. If it does, we know it's a solution. So we're going to have 10 is less than or equal to 3 times 6 minus 5. 3 times 6 is 18 minus 5 is 13. Is 13 greater than or equal to 10? Yes, it is. So we know it works for the first equation. Now we try it with the second equation where we have 10 is greater than or equal to 6 plus 2. 6 plus 2 is 8. Is 10 greater than 8? Yes, it is. So we know A is going to work. Now we test out the points for B, 1, 4. So we're going to have 4 is less than or equal to 3 times 1 minus 5. 3 times 1 is 3 minus 5 is negative 2. Is negative 2 greater than or equal to 4? No, so because it doesn't work for 1, we know it's not going to be the solution overall. And so then we check the last point. So we have 15 is less than or equal to 3 times 8 minus 5. 3 times 8 is 24. Minus 5 is 19. Is greater than or equal to 15. Is that true? Yes, it is. So then we check the second one. So 15 is greater than or equal to 8 plus 2. So 15 is greater than or equal to 10. That is also true. So A and C are our answers for the first one. So you might have two possible solutions on here. You might have just one. It just kind of depends on the points and the problem. So you'll have to check all of them to be safe. All right, the next section we're looking at, determining the number of solutions in a system of equations. So systems is your keyword for this lesson, systems. So looking at number 4, we have 3x minus 4y equals 13 and y equals 3x minus 7. So we need to convert these into slope-intercept form. This equation already is. The first one is not. So we'd have to subtract the 3x. So we'd have a negative 4y equals negative 3x plus 13. Divide everything by 4. Negative 4. We'd have y equals 3/4 x plus 13/4. Now, looking at these, how many solutions are they going to have? Well, there's going to be one solution. Now, how do we know that? Because the slopes are different, which means they are not the same line. They also are not parallel lines, which means they have to intersect somewhere. So different slopes. So that's what you guys are doing on these, converting them to slope-intercept form, and then you're going to look and see if they are the exact same equation. That means infinitely many solutions because they're the same line. They have the same slope and the same y-intercept. If they have the same slope but different y-intercepts, then it's no solution because they're parallel lines. So be very careful with that. All right. Next, we are solving each system. Write your solution as an ordered pair or indicate if it has no solutions or infinitely many. So we're going to take a look at number 8. So looking at this, we can use elimination because our x's have the same coefficient. So x minus x is 0. 4 minus 1 is 3y equals 6 minus 3 is 3. Divide both sides by 3. So we end up with y equals 1. Now we plug that back in. So I'm going to plug it into the bottom equation. So we have x plus 1 equals 3. So we have subtract 1, x equals 2. So our solution is the ordered pair 2, 1. So like it said, there's going to be a lot of no solutions and infinitely many solutions in here. There's a lot of solving system of equations. So we're going to take a look at 18 and 17. So on 17, our equations are in different orders first and foremost. So what we want to take and do is simplify these out some, put them into slope-intercept form. It'll make it a little easier in this case. So the bottom equation would be y equals 1/2 x plus 1. The top one, we just have to divide everything by 2. So we're going to end up with y equals 1/2 x plus 1. What do we notice about these two equations? They are the exact same, which means this is an infinitely many. All right, our next one here. These two also look fairly similar, except one's got all 2's, the other has all halves. So if we divide everything in the first one by 2, we'd end up with y equals 1x minus 1. In this one, if we divide everything by 1/2 and rearrange it, we'll end up with y equals 1x, and then 1 divided by 1/2 is going to give us 2. So are these the exact same equation? No, they are not. So it's a no solution. Okay? So be very careful when you're solving these. Obviously, I skipped around I just simplified those to see what their equations were rather than trying to use substitution or elimination to take and solve. I was able to recognize their similarities right off the bat. But be careful if you need to take and solve it all the way through. Don't take and try to just simplify. Sometimes simplifying helps, but other times it might just get you confused. But whatever works for you. All right, the last section, graphing two variable inequalities. So notice all of these are in standard form. Oh, except for 26 because it's got a fraction. But these are majority in standard form. So using the intercepts is the easiest way to take and graph these. So on 23, if we plug in a 0 for x, we find the y-intercept, and 12 divided by -4 is going to give us a -3. So -3 is right here. There's our y-intercept. Make that a little bigger. Now, we do the same thing, but we plug in a 0 for y. So now we have 3x is greater than or equal to 12. Divide 12 by 3, we get 4. So our x-intercept is right over here. Now, because we have the equal to symbol, this is going to be a solid line between these points. Kind of, sort of. Obviously, you guys will do better drawing the line than I will. So there's our line. Now we need to figure out which side is shaded. Well, if we plug in 0 here, that all turns to 0. Is 0 greater than 12? So 3 times 0 minus 4 and 0 greater than or equal to 12. 0 greater than or equal to 12? No. So we shade down here. So be careful with your shadings and what kind of line you have, okay? All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.